Right, thank you. This is good. That's a good start. Anyway, hi, my name's Philip. I work for Cybereason, and I did not think of a third thing to say about myself. This talk is going to be about device guard. We'll understand what device guard is as a feature in Windows. I'll show a couple of VBA-based bypasses, a couple of non-VBA-based techniques that also bypass device guard. And actually, most of these are not counted as vulnerabilities, and they don't have CVEs. But if you'll try to tell your boss, like, oh, the breach happened, but they didn't use CVEs, you will probably get fired. So it doesn't really matter as long as your machine is vulnerable. Anyway, let's begin with a quick introduction to what device guard is. Device guard is an application whitelisting feature in Windows 10. It's actually the successor to another feature called App Locker. Now, application whitelisting, what it tries to achieve is to only allow code that's defined by a specific policy. In this case, it's by a certificate, by a signature, or maybe by a hash, or even by a path. And only this kind of allowed code that's explicitly mentioned in a policy could be able to run on a machine. And this type of feature inhibits an attacker's ability to run arbitrary code on a compromised machine, meaning that even if you are compromised, you still can't do anything you want on the machine. Now, these types of features have a pretty cool threat model because you basically can use anything you can find in the operating system. And there's lots of logical vulnerabilities, which is good for me because I'm really bad at memory corruption. Now, to understand how these features protect against arbitrary code execution, let's give a bit of a more specific definition of what I mean by arbitrary code execution. And what I mean is the ability to interact with the OS freely under the constraints of privilege, meaning that I'll be able to ask the OS to let me do pretty much anything, and I may get the answer that no, access denied, but I still should be able to ask. And the most direct way to achieve this is by having full control of the memory of a process. Basically, I could be able to allocate code and then jump to it, or to use arbitrary syscalls, which is pretty much equivalent because if I can use arbitrary syscalls, I could always just, well, allocate my code, and vice versa. Now, when we're looking at a system without application whitelisting, this whole distinction doesn't really matter because, well, if I have an RC that's a remote command execution, it's basically a remote code execution. Why? Because, well, I can just run a command with my own code, and then my own code runs, and I can do pretty much whatever. But this equation actually breaks the moment you implement application whitelisting, because suddenly, even if you can choose which code runs, you only have a small subset of what's allowed by your application whitelisting policy. So if, for example, you want to implement credential stealing or command and control or something like that, you have a really serious problem because you have an exploit that in your lab is able to launch calculator, and then you find out that when you get to your target machine, you're only allowed to launch calculator, which is probably not what you want to do as an attacker. So application whitelisting tries to break this equation of remote command execution, or command execution equates code execution. And even if you are somehow able at a specific instance to bypass application whitelisting, it's pretty easy to use your newfound arbitrary code execution abilities. So let's say you're executing in a sandboxed process. Many sandbox escapes give you command execution, and you're downgraded to calc. Same thing happens with privilege escalation, most lateral movement techniques. And when you try to do persistence, it's almost always you are allowed to run a command and not you are allowed to run arbitrary assembly or whatever. Now, the way device guard in practice implements this is by defending a couple of different ways to run code. The most direct way is PE files. And this is pretty simple. The moment you have a device guard policy in place, you can't run a PE file that isn't compliant with the policy, meaning that if you just download some kind of unsigned executable, it simply won't run. The other types of the device guard implementations are a tiny bit more subtle. For example, if you try to use PowerShell, which is today like the red teamers, attackers, whatever favorite toolkit, and you don't have a signed, explicitly allowed script, PowerShell will actually run in what's called constrained language mode, which strips PowerShell of most of its power. You basically can't use most of your favorite types and objects and COM objects, etc. And while you can do some offensive functionality using WMI, constrained language mode basically neuters PowerShell, which is pretty unfortunate for attackers. And a very similar thing happens with Windows scripting engines, JavaScript and VBScript, etc. And these mostly communicate, or only communicate with the operating system using COM objects. And what happens when you run a non-whitelisted script is that most COM objects are filtered. So you're able to use things like regex and dictionaries, but you can't really do shell commands, etc. And again, you have this very powerful attacker tool that is neutered unless you're somehow able to bypass device guard. Now, if you just try to double-click an unsigned or unallowed executable, you're going to have this nice blue pop-up that says Windows Defender Application Control, which is another name for device guard, was used to block this app, which doesn't help you in any way. Now, some of the bypasses I'm going to show will actually require you to be an admin, and an admin can just disable device guard, and that's it. But what happens when you disable device guard? First of all, this will come into place only after you reboot the machine, and you will have an event written to the event log. So if you're a defender and you're implementing device guard in your network, the first thing you need to monitor is these kinds of events. And this means that as an attacker, if I do this, sirens should go off in the SOC of whatever organization you're attacking, which is not exactly good. This is why the moment you have multiple bypasses for device guard, even if they require admin, you basically gain the power of stealth, which is extremely important if you don't just want to pen test or something, but if you actually want to gain something from the machine you're attacking, unless you can do everything in like 5 seconds. And also, that's the most common scenario for lateral movement. So basically, if you break device guard on one machine, you can just move laterally and using various admin bypasses and never encounter device guard again. Anyway, let's dive into some actual bypasses. And the first couple of ones are going to use VBA. Now, VBA, or Visual Basic for applications, is what powers my most favorite piece of software, which is Office macros. And while it is made by Microsoft, and it's probably the most ubiquitous piece of software that's distributed by Microsoft apart from Windows itself, it's still uninstrumented by device guard, meaning that macros allow you to basically reach full arbitrary code execution in a couple of ways. First of all, you could just import WinAPI functions and run whatever shellcode you want. And macros also have COM functionality, meaning that you could abuse COM objects to execute techniques such as .NET to JScript, which will also lead you to full arbitrary code execution. And this whole thing is not instrumented by device guard, meaning that nothing is stopping you the moment you run a macro from doing anything you like on the machine. Now, of course, there's the naive approach. I have an Excel file. It contains a macro that I wrote. I need to somehow make the user click on the enable content button, and then my code executes. But that's a really lame bypass because it requires user interaction, and we're already in a post-exploitation scenario. We've said that we have command execution, and we want to upgrade it into actual code execution. So to do something that's not really lame with macros, we actually need to discover how to run macros without user or GUI interactions. Now, uh, this won't be a vulnerability because you're still in a post-exploitation scenario, but still. So the first idea I had to do this is using a lateral movement or decom approach. Instead of making somebody click on a button, you could actually use the various Office COM objects. Pretty much every Office application, PowerPoint, Word, Excel, etc., has its own COM object, and the macro functionality is exposed by these COM objects. Now, even if you have macros turned off, etc., this will not go through protected mode, and you will be able to run your macros. Now, you can't really do arbitrary COM objects locally with device guard, because if you are able to do it, you're able to use stuff like .NET JScript and basically bypass the feature altogether. But if you're doing this remotely, there's nothing stopping you if you have admin credentials. So if you're trying to laterally move to a machine with device guard, you could use this to completely bypass it. And it looks pretty much like this. So first of all, I defined some kind of macro string that, in this case, just creates a calculator. And I use a bit of WMI magic to change a registry key, which allows me to inject macros into an Office COM object without creating a file, meaning that I don't really need an actual document on the machine. And the moment I do this, I create the, let's say, Excel application COM object. This could be PowerPoint, this could be Word, that doesn't really matter. And I just add my macro and execute the macro, and that's it. That's all I need to bypass device guard from a remote machine. And my extremely malicious calculator will run. But this was remote, and also it needed admin, which isn't perfect. So I wanted to find out what if I have some kind of technique that will allow me to do the same thing, but locally and with an unprivileged user. And here, we need to understand, when does Office say, oh, I just don't need protected mode, let's just run every macro and whatever. And there are two cases in which this happens. The first is trusted documents. If you've ever run a macro on a machine and try to open the same document, you'll mostly find out that the macro runs automatically and it doesn't prompt you with a button anymore. This is because the document is counted as trusted, and trusted documents will just run macros automatically. I need to do some weird registry games to make this work, so I opted in for the easier version, which is the second one. Documents running from what's called trusted locations will not go through protected mode, meaning that if I have a document in a trusted location, I don't need the user to do anything. I should just run my macro and bypass the device guard. So let's see what trusted locations are. There are actually a bunch of folders that are managed in the registry for each and every Office application. And the default ones are writable by admins, because if everybody could write into a trusted location, then it does not really help security. So for example, we can here see the trusted location for Microsoft Access, this ACC Wiz folder. And as you can see, we have read and execute for everybody, but users don't really have the right permission, meaning that I have to be an admin to write this directory to be able to run my macro without protected mode. And on the registry side, it looks like this. So we have basically a access security trusted locations location 2 key, and it contains a short description of whatever this folder is and the actual path to the folder. But if you look at this, and especially at the path, you'll find the problem. This is found in HKCU, which is writable by the current user, meaning that it does not really matter that this trusted location is writable by admins if the definition of the trusted location is writable by everyone. So all I need to do is to write my own trusted location, which I'm able to do because I am the current user. So I'm again using a bit of WMI magic, the same thing, just changing a registry key. This time, I'm adding a new location called bypass test that, that basically defines ctemp as a trusted location. And then all I need to do is just run Office, in this case, Microsoft Access, with my malicious access DB, and even add this /embedding flag that says, hey, Access, just don't open the GUI because a GUI would be bad. And I can run a macro without going through protected mode, without anybody pressing a button, and turning Office in basically a post-exploitation tool, which is pretty cool, I think. Anyway, Office macros are terrible, and the moment you use them in post-exploitation, you discover that pretty much every single defense mechanism is only meant to work against like phishing or exploitation. So they're pretty easy to bypass the moment you're actually sitting on the machine. So I think we're going to see a bunch of post-exploitation malware that's based all inside of Office sometime soon, but who knows. So what we can do is just block the VBE7.dll file, which is the library implementing VBA, using device guard. So if you can't load the VBA engine, you can't run VBA, which is fine. And this means, hooray, we are now protected against Office macros. So let's see a couple of non-VBA attacks. So we got bored of macros. Now it's time for more macros. VBA is actually not the only type of macro that's available in Office. And there's an older version or older macro feature in Excel called Excel for macros, which was implemented in '92 and has no relation whatsoever to VBA. And this functionality is actually implemented in Excel.exe itself. And it exposes two very interesting functions called call and register, which basically allow you to execute arbitrary functions from DLLs. And the only drawback is that it's disgusting because it's a macro feature that was designed in '92. So at first, I was not able to run actual shellcode. I was able to run a bunch of scripts and command lines, which was not enough to actually bypass a device guard. But Stan and Peter of Outflank actually released a way to run x86 shellcode using Excel for macros, which is exactly what I want. If I can run shellcode, I can bypass application whitelisting. So amazing. Let's have a quick walkthrough through how this works. So first of all, here we're using the register functions, which basically take a DLL name, a function name, this weird JJJJJ thing, which is actually a function signature. And then you can actually use these functions from a macro. So I register the shellcode usual suspect functions like virtual alloc, write process memory, and create thread. And then I could just use them with shellcode that's embedded inside of the Excel sheet. This weird value thing is because you can insert a large byte array in a single cell in Excel, but it won't be able to show you that. So I have all of my shellcode, and Excel just can't show it in the GUI, which is pretty weird. But anyway, the moment you run it, let's say through, again, DCOM, you're able to run your shellcode using no VBA. And what I'm showing here is actually just opening a file and running auto macros via DCOM. But Stan from Outflank actually has a pretty cool script that does this interactively via DCOM without going through a file. And one of the main problems with Excel for macros was that the x64 version was a bit broken, meaning that you couldn't really run like 64-bit shellcode due to some weird data type and calling convention constraints, and you would basically have your stack corrupted and lots of weird stuff. But I've recently actually found out how to run 64-bit shellcode through Excel for macros on 64-bit Excel, and have a short article about it if that's what interests you. Anyway, now I have invoke shellcode, which allows you to run shellcode by Excel remotely, either on 32-bit or 64-bit versions of Office. And if you were wondering, does the trusted folder thing work? It works just exactly the same. You don't even need another example, because you could just steal the old example and then just use it with an Excel file, and that's it. Anyway, so there's a benefit to Excel for macros in relation to VBA, because Excel for macros, as I've said, are implemented inside of excel.exe itself, meaning that you don't have some kind of outside library that you can just block and say, oh, now Excel works and macros do not work. If you have Excel on your machine and Microsoft don't decide to simply disable Excel for macros for everybody, which I think is a good idea unless one of you uses Excel for macros for benign purposes, please raise your hand. Awesome. So no external library to block, meaning that as long as you have Excel, you basically have a device guard forever day, which is pretty nice. Anyway, let's go on to ActiveScript bypasses. Now, ActiveScript is a generic Windows scripting technology. It basically is a way that Windows wanted to allow people to build different applications that could be scripted very simply using all of the available Windows scripting engines, and to build their own scripting engine, which could be used to script whatever applications comply with the ActiveScript standard. So this is actually the technology behind VBScript and JScript, and it's also the target of many recent bypasses, such as Squibbly Do, Squibbly 2, and Squibbly some other thing. So there's a couple different ways to use ActiveScript for bypasses. But first, let's see what ActiveScript is composed of. So we actually have two main components. The first is a scripting host. It's an application compliant with a standard, which you can use any of the engines to script, meaning that if I have Internet Explorer, it actually implements an ActiveScript host, and this is why you can use both JavaScript and VBScript inside of the Internet Explorer. And the other main component is the actual scripting engine, which implements its own scripting language and also all of the interfaces for ActiveScript, meaning that I have VBScript, and I can use it against any single ActiveScript host. This is why it works against CScript and also works against Internet Explorer, MSHDA, et cetera, et cetera. And there's actually a bunch of different hosts and engines in Windows. This is not a complete list. So you have stuff like WNC script. You have things like strobj.dll, which is a scripting host for COM scriptlets. You have MXXML 3 and 6, which implement the Microsoft XML engine. And you also have MSHTML, which is the HTML engine behind Internet Explorer and a bunch of other stuff. And in terms of engines, the most common ones are JScript.dll, which is JavaScript. You have VBScript.dll, and you have JScript9.dll, which is also JavaScript, because you can never have enough JavaScript. Anyway, let's see how Device Guard actually works and how it's implemented inside of ActiveScript. So as I've said before, Device Guard in ActiveScript tries to filter the COM objects you can create. So let's say I want to create a new object, wscript.shell, and I'm running in the context of a non-signed script, meaning that Device Guard will try to stop me from creating really evil stuff. One of those evil things is wscript.shell, which is absolutely terrible, and we should not be allowed to run it. So I try to create a new ActiveX object in the text of my script. Now, this wscript.shell goes into class ID from prog ID, which is a Windows API call that translates this friendly name into the class ID GUID of the same COM object. And this object is then passed on from the engine to the scripting host to a function called isClassAllowed. And under the hood, this function calls another function called WLDP isClassInApprovedList, implemented in WLDP.dll, which is the user mode implementation of device guard. And this function basically just checks my class ID GUID against a hard-coded list of what's allowed to run in a non-signed script. And if it returns allowed, everything just goes on as usual, and I create the instance of my object. And if it's not allowed, you get an exception, and that's it. Your script is done. Now, one way to bypass this is with what happens when scripting hosts don't have this isClassAllowed function implemented. And what happens is that the scripting engine defaults into, well, just allow the class to be created. So if I have a class that just doesn't implement it, that's it. I've subverted device guard. And one such class is the ActiveScript consumer, which is a WMI executable that implements the WMI eventing script consumer. It's implemented in strconst.dll, and it's basically an independent ActiveScript host by itself and does not implement device guard, meaning that any engine running under strconst.exe will simply run any COM object that you require, no matter if the script is signed or not. The only downside, it's available as admin, which is, well, too bad. And this is actually the thing that implements WMI persistence. So if you've ever seen this, tried to catch this, or used this, implementing a device guard bypass using ActiveScript consumer is exactly the same. What you need to do is to create an event filter which basically says every time that something happens, in this case, Win32 process called Notepad is created, you invoke your event consumer, which in my case is this name test with a script of run cmd. And then I bind my filter and consumer, so I have this event that every time that Notepad is executed, CMD is executed. And that's about it. And as you can see, if you ever implemented WMI persistence, this is exactly the same with no modifications whatsoever. Another scripting host that does not implement device guard is the Microsoft XML engine, which is implemented in MSXML 3 and 6. And these use what's called XSLT files. Now, XSLT is a format that's designed to help you transform XML files to another format, or which could be XML, or it could be something else entirely. And XSLT actually supports embedded scripting, meaning that you can use JavaScript or VBScript or whatever to help you transform your XML. And the scripting host for MSXML is implemented in MSXML DLL itself and does not support device guard, meaning that the moment you are able to apply the XSLT transform of your choice to an arbitrary XML file, does not really matter which XML file it is, you could run your script, not be intercepted by device guard, use something like .NET to JScript, and that's it, you're running arbitrary assembly. Awesome. So one way to do this is by using the application transform XML method of Microsoft Access. Yes, there's a lot of Office in this talk. What it does, as you may guess, is just take an XML file, take an XSL transform, and apply the transform to the XML. And of course, there's a very polite script option which asks you, do you want to run the scripts on this? And yes, I do want to run the scripts on this. I don't care about XML. So you can pretty much do it in 4 lines of PowerShell. You create the access application COM object. You create a new you create a new access database. You get the URL of an XSL file, which will be both the XML file to transform and the transform to apply, because again, we don't really care about the identity of the original XML file. and just call transform XML with our XSL file. And in this case, it will run Notepad, but it could run .NET to JScript or any malicious thing that you would like to. And I also supply like a non-existent path because, of course, my XSL won't be actually able to transform an XML file, and it will throw an exception. But that doesn't matter because my script is running. I don't care about the XML itself. And if you want to see a quick implementation of this, there's a link at the bottom. Another way to run XSLs is by modifying a lateral movement method by Matt Nelson of SpectreOps. And it's by using the Outlook COM object. And Outlook actually allows you to create almost arbitrary COM objects using the create object function. And we can use it to create this free-threaded DOM document, whatever, which is basically a COM representation of an XML file. And also MSXML2 XSL template, which is a COM representation of an XSL transform. And again, do pretty much the same thing. We just apply our transform, which contains a malicious script, to our XML file, and that's it. The script executes, nothing stops it from running whatever arbitrary code it wants, and we are again running whatever we want. All right. So when I showed you this graph, there was a small lie by omission, and we always see that, well, the script calls something, and then class ID from prog ID is called from the engine, etc. And then the host as class allowed is called. So almost all of these arrows are actually just imports. But the second arrow from the engine to the host as class allowed is not an import. And there's something interesting about how this function is called. And the thing is that there's no single implementation of when and who calls this function, which was actually the basis for a vulnerability because of inconsistent implementations. So let's look at two of them. At the top, we have the JScript9 scripting engine running under the MSHTML scripting host. And we can see that I want to create a new ActiveX object. This may be wscript.shell. And JScript9 calls create object from prog ID, then calls can object run, which subsequently calls host query custom policy is safe to and whatever, which are some generic safety check functions in MSHTML. And MSHTML decides, oh, and I also need to call is class allowed, which is our treasured device guard function. On the bottom image, you can see something a bit different. We have JS create object in javascript.exe. .dll. We have get object from prog ID, and is class allowed is called directly. Now, both of these work, but this small difference is, as I said, the basis for vulnerability. And what happens here is that MSHTML itself calls its own is class allowed function, meaning that basically the team that developed device guard for MSHTML decided it's our responsibility. Whenever somebody checks anything related to security with a COM objects, we will call is class allowed and check everything against device guard. And apparently, the developers of C script or W script, etc., just say, well, anybody who develops a scripting engine will want to use device guard, so let's just give them a pointer to the is class allowed function, and then whoever develops the scripting engine will call it whenever necessary. So again, as you can see, JScript calls is class allowed directly. MSHTML calls is class allowed by itself. So we have two pairs of implementation. In one pair, we have both teams thinking that the scripting host is responsible for checking if the class is allowed. And in the other pair, we have both teams of developers thinking that the engine is responsible for checking if the class is allowed. Now, this is how it works naturally, but as I've said before, every scripting engine should be able to work with any scripting host. because of the ActiveScript interface implementation, meaning that there's really nothing prohibiting me from using one type of implementation with the other. So the developers of JScript 9 never thought that it's going to be used outside of MS-HTML as a scripting host, meaning that they don't check for themselves if the class is allowed. So if I'm trying to run it under CScript, JScript 9 never checks is class allowed. CScript just gives the pointer to is class allowed and says, the engine will check it. So it never checks by itself, meaning that is class allowed is never called. Nobody checks for the validity for the validity of the COM object, and I can create pretty much anything I like under CScript. So this is actually really easy to exploit. Here we can see CScript trying to run a regular JavaScript file that simply tries to run to execute calculator. And we can see we have this exception, automation server can't create object, which is what you get when you try to create a disallowed COM object. But the moment I provide the GUID, the class ID of JScript 9 as a scripting engine, which is this /e parameter to CScript, I basically override the default scripting engine that is to be used, and instead use JScript 9. So now we have CScript and JScript 9 working together, nobody checking anything, and that's it. I can run my beautiful calculator without anybody inhibiting me. And of course, you could use .NET to JScript or whatever to do the exact same thing and run something that's actually useful. So this vulnerability actually was not only limited to CScript and WScript, because strObjdll, which is the scripting host implementing COM scriptlets, was also implemented in the exact same way as CScript. And the only thing that I was missing is a friendly name, a prog ID, for JScript 9, because there simply isn't one. So all we need to do is to have this run. You have scripting language. You mostly have JScript, VBScript. You have nothing for JScript 9. So if I can somehow call JScript 9, let's say also JScript, then I can exploit this too. And it's really easy to do. So all I need to do is just add a new registry entry under HKCU, binding the GUID, the class ID of JScript 9 to also JScript. And that's it. And now I can use any technique such as regsvr to run a scriptlet, which will, again, run anything I want under device guard. All right. So this vulnerability was patched in November. And the patch was actually pretty good, so I did not find a way to bypass it in code. So we should be safe from this vulnerability, right? Well, almost. So here we have two versions of JavaScript, of JScript 9, on the same machine. The first is the version on my patched machine in Windows System 32. And we check the certificate, and it's valid. And the other one is the vulnerable version. And we check its certificate, and it's also valid. And what does device guard stop? It stops everything that's not signed and valid by a specific certificate. And both of these are signed by the same certificate. And we're in a post-exploitation scenario. So why don't I just choose to run the vulnerable version? Like, who cares if there's a safe version? I don't want it. And this was actually discovered by Jimmy Bain, Bohops on Twitter. And you could still abuse two of our recent bypasses. I used JScript 9. He used MSXML. And you just bring the vulnerable version back, and that's it. You have the vulnerability again. All you need to do is to register it as a COM object, similar to the way I did with the scriptlets. And that's pretty much it. Now, this is a problem with catalog hygiene, meaning that the signature catalogs of vulnerable versions of files are still present on an updated version of Windows. So the vulnerable versions still count as signed and could be used. Now, he's shown it for our device guard bypasses, but this is actually also valid for other stuff. Now, um, the way that Microsoft tried to mitigate this issue is by adding MSXML 3 and 6 and JScript 9 up to a certain version to a Microsoft recommended block list for device guard, which is basically like tons of versions of PowerShell and lots of different device guard bypassing executables. So there's just an XML that you add to your policy, and then none of these things can run because they're explicitly blacklisted. But this is really not enough because this doesn't update with every single Windows update, and also, at least up until now, was only relevant to strictly device guard bypasses. But what if I have an RCE? So I think these are two Project Zero bugs in JScript and VBScript. So what if I have a use after free, and I just abuse that use after free, which still exists in a signed file, and I use it to run my shellcode or whatever. I don't really care that it's not a device guard bypass per se, but it's not deployed in a browser or anything. But again, I'm in a post-exploitation scenario. I can choose to run that vulnerable code. I'm not trying to run anything in a higher privilege, so I could use these old patched RCEs as still viable device guard bypasses. And actually, the scope of this is pretty big. There isn't a bunch of stale catalog hygiene problems as much as there isn't really a thing called catalog hygiene, meaning that the moment Windows updates, unless you're updating from, let's say, RS3 to RS4, all of the catalogs remain, meaning that every RCE that you could somehow reach using some command line tricks is still available on a fully patched machine. And you don't even need to bring your own vulnerable code that's signed, because most of the old code is actually stored in C, Windows, WinSXS. So all you need to do is choose your favorite code execution, bypass, whatever, register it, and use that on a fully patched machine because the vulnerable code is not gone. So I think the way to fix this is to delete the old catalogs of pretty much every vulnerable file the moment you update Windows, or else patching is pretty much meaningless because you could always choose to use the vulnerable version of the code. So that's it for actual device guard bypasses, but let's see what these things could do that give you the benefit, what benefits you could gain from these techniques apart from actual device guard bypasses. So first of all, I've showcased a bunch of different alternative execution techniques. Some of these abuse Office for post-exploitation, which is not something that I've seen a lot in the wild, which will probably bypass a lot of different defenses. And also, there's a couple of AMSI bypasses here. First of all, JScript 9 is not instrumented with AMSI, meaning that if you're running anything under JScript 9, for example, the same exploit that I showed, it won't work as a device guard exploit anymore, but it's still an AMSI bypass, which is pretty much free. You just modify your command line a bit, and that's it. No registry writes, no weird memory patching, just that's it, no AMSI. And this actually gave me the idea for another bypass, which is very similar. There's a third native ActiveScript JavaScript implementation in Windows, but this one doesn't really have built-in ActiveX or COM functionality. So you can't just use it to create arbitrary COM objects. But WScript, the scripting host, actually has this functionality. So instead of doing new ActiveX object, which runs in the engine, you could do wscript.createObject and still create your object, no AMSI, and run your malicious script the way you want. You could also stick a bunch of different techniques together because you could bypass AMSI using JScript or Chakra, for example, and then run your shellcode through Excel, having a bunch of different AMSI bypassing fileless modules, which are, I think, not really sought out by defenders today. And you could do injections without injections, et cetera, et cetera. Anyway, to the conclusion. Most of these techniques are pretty easy to detect if you know what you're looking for. As you've seen, the nature of bypassing device guard means that you need to play with a command line a lot. So command line detections, loaded module detections, a tiny bit of registry and WMI monitoring will pretty much give you visibility into anything related to these techniques. So knowing is half the battle, I suppose. And I think while I've showcased a bunch of different weaknesses in device guard, this is still a really good feature, and it's probably the best way you could do application whitelisting today. But if Microsoft locks down Office, even though it's not an integral part of Windows, it's made by Microsoft, and it's pretty ubiquitous, this will bring device guard from something that's applicable to servers to something that's applicable to workstations without a ton of different bypasses. Also, of course, implement a generic solution to catalog hygiene to make patching actually work well. Also, I'm not sure that I found the only implementation, like the only vulnerability in the implementations of ActiveScript. So fixing that would be nice, like one consistent implementation. And also, if you've read about a bit of Microsoft news, you know that apparently Python is available on the Windows Store. So if today you have a fully updated version of Windows and you just go Python, it will try to install Python. So starting with a more generic implementation of device guard for pretty much everything, I think is a smart move, because what if I wanted to use Java? There's no device guard for Java. So you really need to extend this model to allow people to use different types of code. Anyway, that's pretty much the end. If you want to learn more about device guard or more about weird intersections between Windows internals and red teaming and stuff like that, you should probably follow these guys. And I've based much of my research upon their work. And that's about it. You could ask me questions now. You could ask me questions later. I'm available.
Thank you so much, Philip. Guys, congratulations for Philip.